Find the magnitude and direction angles, alpha, beta, gamma, for the resultant force acting at the origin. We have two vectors, one shown with alpha and beta angles, and one shown with azimuth and elevation angles. And we're given the angles and the magnitude of the forces. I've set up my engineering paper with my given and find information. Let's take a minute and look at our vectors. Vector A is the vector in red. It's got components in all three directions. We can see the X and the Y and the Z components by looking at the edges of the box. Vector B is in blue. The azimuth angle is in the X and Y plane. The elevation angle, phi, is in the Z direction. We're going to find the magnitude of the resultant force and the alpha, beta, and gamma angles for that resultant force. Here's our strategy. First, we're going to define both of our force vectors in Cartesian notation. Then we're going to sum the x components, the y components, and the z components of our two force vectors. That'll give us our resultant force components. Then we'll find the magnitude using the Pythagorean theorem. Then we'll refine the resultant direction angles using alpha, beta, gamma identities. Let's first find the components for force vector A. Note that we're given alpha and beta, but we are not given gamma. So we need to find it using our direction angle identity. Here's our direction angle identity. We're going to substitute in alpha and beta and solve for gamma. Solving for gamma, I get that it is equal to 42.03 degrees. I can now use these relationships to get the x, y, and z components of force vector A. The magnitude of force vector A is 3 kilonewtons. Now we have our x, y, and z components for force vector A. Next, let's look at force vector B. Force vector B is given with azimuth and elevation angles. Since in our example problem, theta and phi are defined the same way they are in this image, we can use these equations to calculate our x, y, and z components. Note that theta is 15.3 degrees measured in the xy plane from the x-axis. Phi is 21.8 degrees. Note that FB is below the horizontal or xy plane. So we're going to take our phi angle, 21.8 degrees, as being negative. The magnitude of force vector B is 5 kilonewtons. Notice that we get a z component in the negative direction, and that makes sense given the angle directions we just discussed. Now we've got our components for vector FA and vector FB. Now we can get our resultant by adding the like components of both vectors. And here's my resultant force vector in Cartesian notation. Next, I'm going to find its magnitude using the Pythagorean theorem. The magnitude of the resultant force comes out to be 6.19 kilonewtons. To finish this problem, we need to find our alpha, beta, and gamma angles for our resultant vector. We will use these relationships to find alpha, beta, and gamma. Fx, Fy, and Fz are our components found above. F is our resultant force. Substituting in our values and then taking the arc cosine for each term gives us alpha, beta, and gamma as shown. And we're done.